So, Uwe.
Thank you. Yeah, it's me again, and I'm pretty happy that still so many people here, so thank you very much. This is the last presentation. Alex will come up on stage later on for the certification part, but I want to give you a very short overview on how we scale. The problem which you all know from today is that's a lot of information and there's a lot of technology and there are different facets of the technology. And now, how do you decide what part do you need for your specific problem, for your specific solution? And so I will give you an overview how the OPC Foundation, of course, already thought about this problem. And then later on, we go into the certification and verification of features. So this big toolbox of features, we need to scale that. And we need to scale it in terms of the services, functions, and features we need in an OPC UA product. And also, of course, we need to scale then about the compliance and the compatibility issues. Because if the one is doing this and the other is doing one other facet of the OPC, then they obviously will not match, and then all the interoperability promise is gone. And so we need to find out, for example, which security we are using. We have different security profiles, and if the one component is using this security and the other is using another encryption, then it will not communicate, right? So we need to be very precise in the description of the product and the features we need. And of course, also for the domain-specific extensions, which we call the companion specifications. So of course, all your equipment then must support the same companion specification, otherwise it will not work, because you cannot understand the complex types that are in the companion specification. So OPC has already, still the very first day, a grouping of functions. So we can group sets of functions and we call that a profile. And they are full-featured profiles. A full-featured profile is a profile that works out of itself. And those full-featured profiles you can then extend with facets. Facets are additional features. And I will give you an example how that works in a minute. So the smallest piece of functionality that we can describe in OPC, it's called a conformance unit. And a conformance unit is a testable piece of functionality. And for each conformance unit, we have a set of test cases to test it for compliance, and then we can certify it. And now we use multiple conformance unit and we compose a profile out of it. So functionality that logically belongs together is then composed in a profile. Here I have the example of an embedded UA server profile. That's a full-featured profile and already contains a protocol. In this case, it's UA TCP. It already contains security. In this case, it's 2 security mechanisms that's already included. And it already includes the address space, which you obviously need to browse through this nice information model that we have created. And it already has functions, the services read, write, and subscribe, that are already included in this embedded server profile. And now, on top of that, we can add for a large-scale server that is able to run minimum 50 sessions. In each session, it can have 5 subscriptions and minimum of 500 items, which are spread over the subscription. So this now makes a bigger server. So it's not embedded UA server anymore, it's a standard UA server. This is a profile we would expect a UA server that's running on a PC-based platform should be able to manage. And now, this profile we also can extend with functionalities. For example, this event subscription server facet. Now this standard server that can hold 50 sessions, 50 parallel connected clients, can also do events. And if the server is able to has methods that can be called, for example, an acknowledge method, then the combination of event and acknowledging events gives you the alarms functionality. An alarm is something you can acknowledge. And to do so, you already need the events and the method facet. And with those facets, you now can extend your server and give it more functionality. For example, historical access or structured data or redundancy feature, but also the device integration profile, so that's an information model profile, or for example, the PLC open profile, and also the pub/sub profiles that are under development. So, and with this concept, you now can very precisely describe the functionality of your server. Here I have the list of profiles for the pub/sub, just to give you an impression. So there are full-featured pub/sub profiles. One is the UDP, UADP cyclic fixed profile, which means it's based on a UDP communication. It's a UADP protocol with a binary encoded message inside. It has a cyclic fixed profile. That means that the data inside that is transported in the message has a fixed length. So this, for example, is the basic that you need for a deterministic transport. Because if you want to be deterministic, then the length of the packet should be constant all the time and not fluctuating, because otherwise you have the jitter, right? So, for example, there's another one here in green, MQTT JSON profile. So that means the transport is obviously MQTT protocol. The message is JSON encoded. So that's the one that you should use for cloud communication. And there are facets, for example, the message security facet. So there's a security facet that describes how the security works inside the pub/sub profiles. And of course, there are configuration facets as well, so you can configure the pub/sub through the client server inside your UA. There's a very detailed description on all the profiles available on the internet. As you can see here, we have a tree. You can drill down into the full-featured profiles for servers. And then I have selected here the standard UA server profile, and you can see it consists of the embedded server profile plus enhanced data change additional features. So, and if you click on it, you can see the list of functionality, optional or mandatory, a description, and how this all composes together. And you can read what the server can do. So now it's, again, a lot of information, but it's a very precise description. Now, in addition to that, a server that has a certain functionality should expose the fact which functionality it has online in the server, because the whole piece should be self-descriptive. And so inside the address space of the server, it's under root objects, server object. You go into the server capabilities, and here the server, actually inside the information model of the server itself, can describe what capabilities it has. There's a server profile array, and that is a list of all the profiles this server supports. So if a client connects to the server, it can drill down into the address space and find out what capabilities the server is able to provide. And then the client can adapt to that and use that function, because it knows that the server supports it. Okay? In addition to that, we have the operational limits. That's information about the volume the server can handle. Because, of course, it makes a difference if you can read 100 variables at a time or 100,000. And if you read 100,000 at a time, maybe the server is not able to do it, because then it's busy for a few minutes, and then you block the server. So a server can protect itself by saying, stop, I have operational limits. You only can call the read function with 20 variables at a time. You can read 100 or 1,000, but only 20 at a time. That gives the server the ability to protect itself from high volume operations. And also this information is exposed here in the address space in the operational limits. So a client can connect, read it out, and then knows, this server, I must go easy, only 20 per 20 per 20 at a time, so that the server does not get overloaded. Okay. Same concept of description we have with the security. You know, we have the built-in security, and we divide that in the application layer security and the transport layer security. And the transport obviously is a confidentiality, so it's the encryption and the signing for the integrity of the messages. We can authenticate applications, but we also can authenticate users with user password or whatever. And with the user authorization, then we have the access on the individual data points in the address space, where we can say, this group of people is allowed to read, the operators are allowed to write, some guests are maybe not allowed to even see. So we all have this inside. And we also describe this with a profile. And this is called the security policy. And the security policy is a combination of the cryptographic algorithm that is used for this security profile, the signature algorithm, which can be different than the one used for the encryption, and the key derivation algorithm. And these three informations are combined in the security policy. And the server can announce, these are the 5 security policies I support. And now the client is connecting, getting the list of the security profiles, and says, okay, this one I don't support, this one is weak, this one is the one I want to use. And so they find a match, and then they can communicate with that. And then they use the same encryption algorithm, and then they can establish a secure connection. And the same concept for the publisher. With the publisher, it's a little bit more complicated because there are multiple receivers for the same message, so they all need to have the same key to decrypt the message. Here are the security policies for the transport. And as you can see, there's a URI that uniquely identifies the security policy. And the first of all is none. And that's obviously nothing. So the non-security policy is a security policy you should switch off in the machine if you go live in production. It's normally just used for testing and for the commissioning phase, but it should be switched off because it's no security. Then, as you can see, we had a 128 RSA 15 security policy, which is already deprecated. This was invented 10 years ago when OPC was invented. And as you know, with all security stuff, over time, it maybe get hacked, it maybe get compromised, and then you need to deprecate it. And the OPC Foundation is doing so. So this one you should not use anymore. There are new stuff coming up with average security, which you use typically on small machines that have not the computing power for the very high encryption algorithms. So we could also only say we only take always the highest. But of course, if you have a very small device with very small computing power, then it is very overloaded by always calculating the keys and always calculating the security. That's the reason why we have medium security as well. And in some use cases, you probably not even need to encrypt the data because you say, it's public, like the temperature of this room, who cares? The only thing you maybe not care is that it's not manipulated. So you can sign the message, but you should not encrypt it. Okay, it's not confidential, but it should be right. But with OPC, you can use either or both, whatever your requirement is. And of course, over time, we probably need to deprecate more, and we need to find new algorithms in the future. Like, for example, the elliptic curve is one we are looking at. That's one we want to integrate. Okay, for the user token, that's for the user authentication on a server. We have different formats. One is anonymous. That, of course, means it's not authenticated. That's like the everybody or guest or whatever you want to call it. So there's no user authorization. And then we have username and password. We can also have user certificates, X509 certificates, or a token. For example, Kerberos token. We have two Kerberos token formats because the Windows one is a little bit different than the rest. And we have a JSON web token, which we can also use in the OAuth2 authentication mechanism, which is, for example, used in Facebook and some other big user authenticated platforms. Now I want to talk about how do you select the list of features you need. And of course, the highest selection point that you can find is the companion specification, because that's the domain-specific description of the things. For example, if you have a robotic spec, it obviously describes how robots look like. And because of that, they already define that they need, for example, complex data. In the companion spec, they probably use methods. Then, of course, the server must have the method facet. And they maybe also already define what other features are required. And with that, automatically, you get the list of profiles. What you need to do here, and that's a list of profiles coming out of the companion spec. By the way, companion spec can be grouped. So one companion spec can be derivated from another one. So in the one companion specification of the robots, it's already included the device specification because a robot is also a device. So with all those, you get then the list of profiles and the facets, and then you, for example, have your automotive device. So it's an OPC server that is used in automotive industry, and it should have the capabilities listed here. What you then need to add is the security policies you want to use and the volume and the speed, so the number of parallel connections that should be allowed. And with that, you get the final, precise, functional description of the UA application. And this is what you should use then for the call for bidding. So if you are in the automotive industry or in the packaging, I would imagine that you have a packaging list for packaging machines with all the profiles needed for packaging. And then you have a very precise description, and if you buy a packaging machine, you can say, oh, by the way, this is the call for bidding. You must support OPC UA. You must support this and this companion specification, and this automatically gives you the list of the profiles. Okay? So with that, I want to hand over to Alex from the test lab.
One question for myself, because you mentioned that from time to time, the OPC Foundation might deprecate security, old security. Now I'm playing the role, I'm a machine builder. I'm offering a machine. I sold that machine 10 years ago, 14 years ago even, right, 2006. And I built in an OPC UA server at that time that was exactly available only on the market as security. I can't update my machine, never change a running machine. Once a machine is running and producing money, never touch it, right? Okay. I know what I'm talking about, yeah. So what does it mean, deprecating it? Is it server or the client? How does it work?
Yeah, so of course, if we talk about cybersecurity, then we all know that the whole thing lives from the fact that you can update the stuff. Because you will always have some security holes in the software. It's either in the algorithm or in the library or it got hacked. So you should be aware that your devices are enabled to be updated, either by a firmware update or by whatever. If you cannot update, as you said, because it's a running machine and you should not touch it, then you should at least switch this security policy off and then use the next higher one, if all the others that are connected to it also support it. If not, it only means that the OPC Foundation has deprecated it. It does not mean that it's now totally unsafe. It's even better than nothing and better than switching it off completely and doing the none policy, right? But of course, when you design a device that should be a cyber physical system and be in an interconnected world, you should consider how to update the thing with a firmware update or whatever to get a modern policy.
Perfect. And second question before we hand over to Alex. When I noticed, and you talked about all the profiles and what should be a part of the package for a packaging machine, for call forbidding, for example, then definitely this is, I think, where you address the audience. I just want to make sure you got the message. You really need to check, is the OPC UA server from that company really fulfilling all the profiles you need? It is not efficient, it is not enough just to say, this one has been certified on the lowest level of I'm a nano server profile or embedded profile. This just says the minimum feature set has been tested, but not really the full feature what you need. And I think this is what you are now more and more talking about, and it's a good momentum to hand over to Alexander Allmendinger. Alexander is running the test lab, the European test lab in Stuttgart, and he exactly knows about all these testing, what are the requirements. Alex, your talk.
Thank you, Stefan. So yes, my name is Alexander Allmendinger, and I'm going to tell you something about certification real quick, because I know I'm the last presenter, the last technical presenter at least. So I'm trying to keep it short for you. Now, when we talk about an open standard, and that is exactly what OPC UA is, the problem is that anybody can use it. Anybody can implement it, and everybody can tell you that it is according to the specification. The problem with that is it doesn't tell you anything about the quality of that product. Now, that is exactly the issue. And it's not necessarily the fact that they did something wrong on purpose or they trying to trick you, but it might be just a different level of requirements or understanding of requirements, right? So that is the problem that you're facing when you're buying OPC UA products. And that is exactly where certification kicks in. Because with certification, we do have a uniform way, a uniform quality guideline that you can trust. And that is exactly what I'm going to describe to you now, what we're testing there in detail. So when we're talking about certification, we're talking about 5 different areas. And I'm going to walk you through each one just briefly. So when we talk about the compliance area, obviously that is one of the most important one, because that tells you whether it's compliant with the specification or not. Now, in that case, we're not only talking about the compliance with the OPC UA core specifications anymore, but we also talk about compliance with companion specifications. And when we talk about compliance, we say that we test every required functionality, as well as any optional functionality that is implemented. Now that means whenever there's something implemented, we're going to test that. You cannot tell a certification lab that you don't want to get a functionality tested because you know it's broken. That's not what's happening here. So whenever you see a certified product, all the features inside that are testable and certifiable, they have been tested. Now, what we're testing there is basically, the way we test it is, we're testing test cases that we expect to pass, that is just normal usage, but also test cases to fail. So what we're testing or verifying here is that any product, any UA product that has been certified is able to handle invalid requests, invalid, like the whole telegram is not valid, but also the content is not valid. For example, we remove all the results in a response and ensure that the client is not crashing. So stuff like that. So we really ensure that those products are handling these things well. In order to test that, the OPC Foundation has a compliance test tool, the so-called CTT, which tests your compliance with the OPC UA specification in more than 1,000 test scripts. And we keep enhancing that. So that validates like security, but also the address space. And the beauty of that tool is it can be extended for companion specifications. It can be extended by any vendor. So if there's something specific that you want to test that is on OPC UA functionality because you want to test something in your machine, you can easily do that. You can just add your own test settings, your own test scripts, and make that happen. The next area we test is the interoperability, because that is the reason why everybody is implementing OPC UA. Now, in OPC UA interoperability testing, we say that we connect at least 5 UA products from different vendors. So that is the minimum. Sometimes we do more. It really depends on the product. And we choose those products wisely. So we use products that you might meet or that you will meet in the market. And we use products from different vendors, different SDKs, different stacks, different programming languages. So we really ensure that this interoperability is working. And all the products that have been used for the testing are mentioned in the test report. So when you take a look at the test report as an end user and you see that the interoperability has been tested between 2 products that you use or that you want to use, you know that this is working. And with that, we test basically everything, all the data types, the security policies, the user tokens, just anything that you would use as well. That gets me to the next area, the robustness. So in robustness, we're talking about the handling of communication breakdowns. And that means like short breakdowns, midterm breakdowns, and long-term. Now that makes a difference because in OPC UA, or the OPC UA technology is architectured in a way that you can keep or recover missed data, at least to a certain amount. And that is exactly what we verify here. So we ensure that after a connection break, all the lost messages are recovered. So all the data is basically requested by the client again and the service providing this information. But that is not limited to the communication between the OPC UA client and the OPC UA server, but also to the underlying devices, to the data sources, because that makes a big difference as well. In part 8, OPC UA basically describes you the rules on how to map a communication state to an underlying device. So that means that a status code of a UA node of a variable needs to change to bad no communication, for example, if the connection to the data source is broken. So that is providing all those metadata that makes OPC UA strong. And that is why we test and verify that when doing certification as well. Another very important thing here is that we ensure that those problems are self-contained. Because if I break the connection to the data source and I send you a read request, I don't want to see that another client is basically not getting data updates anymore. So data change notifications, right? Because all the clients need to be separated. They need to be handled different. And that means that we don't want to see like blocking actions. So when you use a certified product, that basically tells you that you can rely on the fact that this is not going to lock down. And in order to verify all of that in a longer term, we do have the area efficiency. Now, efficiency for us means that we execute a long-term test and combine all the 3 areas that we talked about. So we place the product under some load, and that might be like 500 nodes if that is all the server supports, but it also might be like 50,000. And we ask for changing data. We do that with all the clients that we used for the interoperability testing. And then we're going to force intermittent connection to one communication partner and to a data source. So the way that we do that here, and then we keep that running for a long term, like at least 72 hours. So that is how we ensure that the product is not having leaks, because we monitor all the memory, all the CPUs, the handles, the threads, and we ensure that this product is not having a leak and will run for a very long time, right? The last thing that we also take a look at is the usability. And usability for us means that we're really going to take a look at the manuals, at the documentations. And we ensure that the information inside is providing an end user everything they need to operate the product. For example, or a best example is always certificate management, because the security in OPC UA only works if you have a working certificate management system. Now the problem with that is, if that is not well described, how you trust certificates, where you need to place them, how you can update them, how you can reject something that you already have trusted, that makes a nightmare for the end user. So we read all those documentations and we provide feedback on how to enhance it, how to make it better, how to give your end users a good feeling about the product and provide them all the information they need. After you did all of that, you get a certificate, of course, and you get the right to use the Certified for Compliance logo of the OPC Foundation. So that is the way a vendor can indicate to you that a product has been certified by a certification lab. And that is what we encourage you to look for and ask for in your call for biddings, because then you really can trust on the implementation. But that is not all you get, because that is just a starting point. So if you see a Certified for Compliance logo, you might want to know what exact profiles have been tested, what version of the product has been tested, which compliance test tool version has been used, and when was the certification taking place. Now all of that is something that you can find in the OPC Foundation product catalog. So you go on the OPC Foundation website, and under products and certified products, you will find the list of all the products that have been certified. And you find exactly those informations. And you actually even see all the certificates that they have gained. So you see the quality that a vendor put into his product. For example, if they have been certified for 101, 102, and 103 version of the spec, well, you can trust on the quality of that product quite a lot, right? Because you know that this is like a long lifetime and they will have enhanced. What we are also planning on to enhance, and that is something that you will see in the near future, is information about the so-called IOP workshops. IOP is interoperability workshops, and the OPC Foundation holds 3 of them in a year. And what we do there is basically all the vendors, all the members of the OPC Foundation, all the corporate members are invited to join and test the interoperability between the products. So you will see all the vendors there, and they test the one PLC with the HMI and the PLC with the PLC, and everybody, all the different vendors are trying to communicate. And that really is another quality statement. So if you see a product that has attended a lot of different IOP workshops, that can give you the trust that it's well architectured and that the interoperability is on a very high level. So I can only encourage you to take a look at the product catalog and see exactly that information for products that you want to purchase. But that is just a starting point, right? So it provides you the information about the certified profiles, facets, security policies, and all these things. But obviously, there's always more to it. Now, what you get after certification are different kind of test reports. And there is one report that is called the test report summary. And that is basically what you see with the first 4 pages. So we redesigned that just recently. And it is now a bit more than just 4 pages, but it really provides you a good overview over the functionalities and profiles that have been certified. So that is providing you information about the policies, the security policies that are supported, the profiles, the facets, even optional conformance units, whether they support it or not. That is something that you would not see on the web page. But also notes from the tester. If there is something important that you should be aware of, it will be listed here. And that is why I can only encourage every end user to ask certified certified products for exactly that report and take a look at it. They also do get test records. That is basically every single test case that has been executed. Now that is a very long list, so usually end users are not going to take a look at that one. And the same is for the efficiency test, where we do create graphs whenever we are able to do that. Right, so we basically create the graphs of the memory usage and handles over the time. And that is all that I'm telling you on behalf of certification, because like I said, I kept it short, I kept it briefly. That's a lot of compressed information, but it tells you that certification in OPC UA is not just checking a document. We really test that product in a certification lab. There's an engineer taking a look on every detail, and the logo is not just something that you get easily. You need to work for it, and that is exactly the value and why it's been honored by the many end users already. So thank you.